Welcome to the Software Engineering channel on YouTube. Today we're going to start with your very first C++ programs. So before we jump into it, there's something we need to cover, which is how the programs are actually created. So here's the flowchart. You start with any sort of text editor. We're going to use Notepad++, but any text editor will do. There are also some integrated development environments. We'll look at those later on in the series, but for now we're going to kind of work our way from the ground up. When you run the compiler, the first thing that gets run is the preprocessor. It runs through and basically it'll look for specific things in your text files and do those actions before it even tries to compile. Then it actually gets to the compiler phase where it checks for syntax errors. If there's syntax errors, it'll direct you to where those are and you need to go back to the editor and fix those. If that works, then you can go to the linking phase where it'll pull in the libraries that you might be using and link them together into object files. Those object files are files that will eventually get compiled into the executable when you get to the next phase, which is the loader phase, where you have all these different object files and it combines them all together and makes your machine code into the executable. You can have various errors at each one of these phases. The most common errors you'll find are at the compiler phase where you have syntax errors. Moving on to methodologies. Methodologies determine how the source code is organized. Some languages make it easier or harder to use certain methodologies. So why would you choose one? Well, there are four main reasons that you would want to consider a specific methodology: the correctness, the maintainability, the flexibility, and the reusability of the code. So we'll look at the functional decomposition. This divides the program into phases where you have algorithms for each phase. A good example of this is Fortran, where everything is broken up into sections and each section gets run and you can bounce around between sections. The next one is structured programming. This uses functions to make the code more readable. Fortran can also do this in newer versions. C and Pascal are also examples of this. Modular programming groups related data and functions together. These modules operate on, or the module functions operate on module data. C and Ada are good examples of this. Then you have object-oriented programming. This is a formal convention where the modules are combined into a what's usually called a class or an object, where the data for that is hidden and you have member functions that are either private or exposed depending on what they need to be doing, and they operate on the data. It's a formal construct, whereas the modular programming is more of an informal construct. And then finally we have generic programming, where your functions are your interface and then that's shared, so you have algorithms and the functions are what's reusable as opposed to the data structure. So with that, we're going to jump into our first programs. So I'm going to use the Windows subsystem, or sorry, the Linux subsystem for Windows. So here we're going to start, and I use a single line comment. Let me change the language here so you get the syntax highlighting. So in C++, and we'll go over the actual syntax in another video and go over the various data types. This is just a brief introduction. But a single line comment can start with a double /, and you can put that anywhere on a line. Anything after that will be considered a comment. So we'll put so here I'm using the preprocessor directive to include, and I want to include the input-output stream library from the standard library. We'll go over the standard library also in another video. For now, this is all you need to know about it, is that I need to, if I'm going to do input-output stream in the console, I need that library. And there's a whole bunch of other preprocessor directives that we'll also cover later on. The include one effectively pulls the header file, which is the IOStream header file, into my file. It's almost like it's copying the whole thing into that chunk. So it's, if you imagine this line actually being a few hundred lines where the contents of the IOStream header file has been copied there, that's effectively what it's doing. Before I do that, So here we have the main entry point for all C++ programs. You have a function that has a return type of integer and a name of main, all lowercase. You can have some parameters in here. For this program, we're not going to be using any parameters. We're not going to be taking command line arguments. But when we get to the point where we are looking at command line arguments, you'll see parameters here. All C++ programs, regardless of what platform they are on, have a main function somewhere. Some platforms, such as Windows, if you're writing a Windows user interface program, will hide the main program from you. So you'll have to implement winMain, but if you follow it underneath the hood, eventually there is a main function being called. So this is the main entry point for all C++ programs. Alright, so here I'm using the IOStream library, which gives me an object called cout. This is the standard library prefix for the standard library namespace. And so I'm saying I want to use cout. This is the insertion operator that, when you're dealing with input-output streams, allows you to put various data types, in this particular case text, and shove it into the stream. And I'm saying I want to print hello world, and then I want to end the line, and then I'm going to end the program. So here I will save this. Let's make a temporary folder here. Alright, so now I've saved my source code. This is the editor I've used. Save the source code. So now I'm going to come over to the command prompt, go into the directory I just created. G++ is the compiler we'll be using for this. And I want to compile it to Alright, so that compiled it. So now if we look, you'll see I have a main.o file in addition to the CPP file that I just created. This is the object file that gets created once the compiler has finished its output. So now I want to convert that object file into an executable. So I'll use G++ again. Tell it that I want to oops. Now I have the executable hello world. So if I run it, it will print hello world, just like we saw here. And that is your very first program. Alright, so now let's do one that's a little more complicated. So I'm going to come up here, I'm going to create a new file. I won't include the comments that I put last time. I'll just go ahead and... Did I select the right language? Okay. Alright, so this time I want to calculate the area of a rectangle. So I'm going to have area and perimeter. So I'm going to have two functions, and I'm going to limit it to whole number lengths and widths. So we'll say that I can spell it. Here we go. Alright, so here what I've done is called for declaration, meaning I've defined what these functions will look like, but I have not yet implemented them. What this will allow me to do is use them in functions. So I'm going to declare and implement main here in a second, but I have not yet implemented, so I can use it in main without causing a problem, because it's telling the compiler this will exist when you get around to linking. Don't worry. For now, I'm going to hard code the length and width. So we'll say let me go ahead and line here. Alright, so now, if I were to save this, let's go up one, create a new folder. So now, if I were to notice that it compiles. However, I have not defined what these two functions do. So if I come in and now you'll notice, oh, whoops. You'll notice that I have undefined references to these functions. So let's define what those functions are. So for the area of a rectangle, it's length times width, so we will return L times W. Note that this is saying that I'm going to return an integer, and I'm taking an integer that's going to be named L for length, another integer that's going to be named W for width. So here I'm specifying the return value is going to be the length times the width. There are other data types. We will get into that in a separate lecture. So for now, just know that this is an integer, which is a whole number. And I'm actually using a signed integer here, so it actually could be negative, but in practice, this is probably always going to be positive. So you could actually change this to an unsigned integer without any problems. So now the perimeter is going to be 2 times the length plus the width. So you end up with 2 lengths, 2 widths. Right? So now I've defined both of those functions. So now I can come back and recompile. And I no longer have the error at the loading phase. But I also have my rectangle program. If I run it, you'll see that it now prints out the proper area and perimeter for the rectangle. And you can check that. So that gives a slightly more complicated example. Now, let's say we didn't want to hard code these numbers, we wanted to pass them in. We're going to introduce the command line parameters here. So here, this is how you would pass in command line parameters. This int argc is the number of arguments on the command line. It will always be at least one, where the first argument is the name of the program. And then argv, it's an array of strings that are the actual arguments themselves. So I'm going to do two things here. One, I'm going to include actually, I don't need string. I can just do so I'm going to first define my variables and initialize them so that they aren't in a bad state. And now I want to read them from the actual argument. So I'm going to assume that argc So if I don't have three arguments, in other words, if I don't have the name of the program, the length, and the width, then I'm going to exit the program because you didn't give me what I wanted. So this is going to return, it's going to print out invalid arguments and return instantly. If it was three, then the first argument, like I said, is the actual name of the program. The second argument will assume to be the width, or sorry, the length, and then the third argument will be the width. This is not the only way to do this, but I want to demonstrate. So what this is doing, I'm temporarily putting the actual argument value, which is a string, in a stream that I can read, and then I'm going to read it in using the same syntax that I'm using down here for the cout, just the opposite way, so that I can read it from the command line. So now if I come back over here and compile, helps if I put the right stuff there. So now I'll use the same ones I used before, which were 10 and 23. And you see I get the same output. So now that allows me to pass them on the command line. What if I wanted, instead of passing the command line, to actually read it in the program? So I can change that to do that as well. To do that, I can ignore all of this. So here I'm going to introduce the idea of a block comment. Here, the /* starts a block comment, meaning everything after that until I close it with a star and / is considered a comment. You got to be careful with that, because if you use a block comment and don't close it, it means that the rest of the file is a comment, and that will likely mean that you have some compiler errors that you're going to have to deal with, because you're not going to have closing tags and whatnot. So keep that in mind when you're looking into it. But here I can and here you'll see why I went with the string stream in the previous version of this example, because I can use the exact same syntax here. Right. And there are some error checks that typically you would do. I'm skipping those for the sake of brevity and the sake of clarity for the examples. We will get into that later on. So now I can prompt it. And again, I get the exact same answers that I expected before. All by changing where I wanted to pull the inputs. And with that, there are your first 2 C++ programs. In the next lecture, we will start looking at different data types and how to declare functions in a more detailed fashion.